What we have before us are data for 20 countries on 4 variables. The first variable is life expectancy at birth, measured in years. The second variable is percent of the population that resides in urban areas. The third variable is public health expenditures measured as a percent of national GDP. And the last variable is average years of education. These data come from the UN Development Program database from the year 2015. What I will do in this tutorial is demonstrate how we can construct a correlation matrix for these 4 variables. Now, the correlation coefficient we'll be generating is Pearson's R, also known as Pearson's product moment correlation coefficient, and is the standard measure of correlation between quantitative variables. To do so, let me first of all take the variable titles, or labels rather, and place them over here to generate our matrix. Now, what I'm also going to do is take those variable names and place them in this column. What I'm going to do is use a special transpose option under the paste options, and you notice it takes a row and turns it into a column. Now, the first function I want to demonstrate is that of the Pearson function, and I first of all will generate a correlation of life expectancy with itself, which of course will be a value of 1. Typically you'll see that correlation matrices will have a diagonal of 1s for these correlations among each of the variables with themselves. What we'll do is first of all highlight the first data array, comma, and then I'll highlight the same data array again, close the parentheses, and hit return, and there you see a correlation coefficient of 1.00. Now, to generate the correlation coefficient of life expectancy with urban, equal Pearson, open parenthesis, first variable life expectancy, comma, the second variable is urbanization. We'll do the same thing for the next variable. And for the third. And now we have our Pearson's correlation coefficients for each of these 3 variables with life expectancy. Now I'll drop down and construct a Pearson correlation coefficient for the variable urban with itself, which of course should give us a value of 1. And we'll generate a correlation coefficient of urban, comma, with health expenditures. And then urbanization with average years of education in a country. Let's go to health expenditures now. Now, first of all, generate a correlation with health expenditures with itself. Oops. Should be a value of 1. And now with education. And lastly, I'll just finish this up by generating a correlation of average years of education with itself, and there we finish off a diagonal of 1s. Now, to make this look a little nicer, perhaps I want to reduce the number of decimals that are reported so it's consistent for all of these. We really don't lose that much. Precision, taken out to the 3rd decimal, should be fine for most purposes. And right there we have generated our correlation matrix. Now I want to demonstrate also a second function in Excel that works the exact same way, but this is the CORREL function. And we do it the exact same way. Click and drag to highlight the first data array, that first variable, and then for the second variable. And you see it generates the exact same value that we had before. And if we use the CORREL function for each of these other coefficients, we would get the exact same result. The reason why there are two different functions in Excel that generate the same statistical result is my understanding that before the year 2003 or 2003 versions of Excel, there was only the CORREL function. And then in 2003 or shortly thereafter, the Pearson function was created, but there still were problems with the CORREL function in terms of error would come in terms of rounding. But Excel kept the CORREL function in to make it compatible with previous versions in the event that someone had created a spreadsheet that still uses the CORREL function. But now those issues have been addressed, and you will find then that the CORREL function and the Pearson function generate the exact same result. And this is how we go about generating our correlations for quantitative variables in Excel using functions.